Hey everyone, welcome back. If you are a regular viewer of this channel, then you already know what this video is about. And my apologies for bringing this out this late. And thanks to all of those good people who reached out to me on LinkedIn to thank me for my last video. With your encouragement, this is what you asked for. So recently I imagined being able to upload a medical report, whether it's a PDF or an image, and instantly extract key information and be able to ask questions about that report and get personalized recommendations backed by an expert medical knowledge base. I built that app and submitted it to Google's developers competition. While I am awaiting the results, I was asked by my viewers to create a tutorial for that. In my last video, I have shown how I created the entire knowledge base for free. In this video, I'll build a Next.js app that leverages that knowledge base to answer questions about a patient's medical report using the Gemini model. Here's a quick demo of the app that we are going to build. On the top left, you can choose a report, and I'm going to choose an image that I have taken of a sample CBC report, and you can choose a PDF as well. I'm going to click on this upload file button, and then it is going to extract using the Gemini's vision capabilities the details that are present in the report. So here you have the ability to edit this and make corrections and add details like patient's age, gender, or any symptoms that might be relevant to generate a specific recommendation for the patient. So after that is done, you can click on this looks good button, and you can see that the report has been added. And here you can ask how is the report, and click on this ask button. So here it is querying the Pinecone database to extract all the relevant details that are relevant to this report summary as well as the user query. Based on that, the Gemini is going to create a more informed recommendation for the patient. So here you can see we have also implemented the streaming feature of the LLM response. Since the report is a CBC report, so it talks about possible anemia, borderline low platelets, etc. It also talks about further testing and all of those things. So if you click on this relevant info, and this section is not to be there in the final app, this is just to test whether the RAG snippets were relevant to the patient's query or the patient's report. If you see, it talks about the hemoglobin levels, etc. It talks about the possibility of anemia, the causes of anemia, talks about platelet counts, WBC, RBC counts. So I'm taking the top 5 matches and I have numbered them as clinical finding 1, clinical finding 2, 3, 4, and 5. So all of this, you can see that they are talking about platelets, mostly related to blood, etc. Using this auxiliary information, the LLM will be able to generate a more informed recommendation that is more useful in a medical use case. And we'll also implement dark mode for nighttime use. And what you saw in the intro is this app in mobile browser where you have the option of opening up your camera and click a image of a medical report. Now, since I'm on desktop, I won't be able to show you that, but I'll leave a link to this live website under this video. Feel free to go to that website and grab a medical report and let me know what you think about it. And if you like this app, then feel free to go ahead and upvote my app in the Google's developer competition. I'll leave a link to that as well under this video. So with that, let's go ahead and let's build this from scratch. Okay, so we'll start by creating a new folder on our desktop. We'll call it almost MD, and I'll drag and drop it onto the VS Code icon so it opens up in the VS Code. Here I'll bring up the terminal using Command J. In the terminal, I'll write npx create next app @latest dot, so that it creates that boilerplate Next.js application in the specified directory itself. It is going to ask for some configuration. I'm going to say yes for the TypeScript and ESLint and Tailwind CSS. I'll not use any source directory, apt outer yes, and I'll not change the default alias here. After that is done, I'll go to the app directory and onto the page.tsx file, and I'll delete everything that comes with the boilerplate code. And here I will use tsrafce, the ES7 Plus code snippet, to create a home component. And if you cannot use the ES7 Plus code snippet, then you can install the ES7 Plus plugin from extension panel. So you can hit Command Shift X to bring up the extension panel, and here you can search ES7 Plus, and this is going to be the most downloaded one at the top. So here I'll also initialize ShadcnUI. As you know, ShadcnUI is one of the most popular UI libraries at this moment for Next.js applications, and I'll be using a lot of UI components like buttons, text area, label, etc. And ShadcnUI will help us to get a basic implementation of that, and it will also allow us to modify the look and feel because it brings over the code onto the project directory. So I'm going to write npx shadcn @latest init. It's going to be init. So this is also going to ask for certain configurations. I'm going to go with the default theme and neutral base color, CSS variable yes. So with that, we have a basic Next.js application setup. So let's go ahead and bring up the service to see if everything is working fine. So I'm going to write npm run dev, and it opens it up in localhost 3000. So I'll bring up Chrome. So this is how I'm going to set up my IDE. On the left side, I'll be writing code, and as and when I save any changes, this is going to reflect on the right side in the Chrome window. So this is the sketch of the web app that we are going to build. So it has basically two components. On the left side, there is report component, and on the right side, there is the chat component. In the report component, the user can upload a file that can be a PDF or an image file. And when the user clicks on this upload button, it uses the Gemini Vision task to extract the report details. And the user can also edit, make corrections, add some important details like patient symptom, patient's age, and gender, all those things. And after that human verification, the user can click on this looks good button, and then the user can go ahead and ask questions about the report. So the user can ask questions like, how is the report? What should I ask my doctor? And that will be done in the chat component, where that report details along with the relevant retrievals from the RAG knowledge base will be used by the Gemini model to answer questions about the report. And on the top right, we'll be building the theme toggle. So we'll be building the dark mode using the ShadcnUI. Now on the mobile screen, since it will have limited real estate, it will primarily feature the chat component. And here on the only difference will be on the top, there will be a cog icon. When the user clicks on it, there will be a drawer component coming out from the bottom, where there will be the report component, where the usual report component workflow, that is the selection of the report and the extraction of the details and the human eye verification, can be done by the user. And when the user clicks on this looks good button, it will show in this badge that the report has been added, and the user can go ahead and ask the questions. So back in the code, I'll remove this div and start writing div. I'll give it a class name, grid, height, screen, width, full. And inside the div, I'll create another div with class name flex column. And inside that, first I'll write the header. So this will have the name of the website, that is Mr. Almost MD. And on the right side, there will be the theme toggle button in the desktop version, and in the mobile version, there will be an additional settings button, which will trigger the drawer component. So I'll give the header some class names, sticky, top 0, z10. So it is above everything else, and it will have a specific height, that is 57 pixel, bg background, flex, item center, gap 1, border bottom, and padding x of 4. Inside the div, I'll write a h1 tag and give it class name, text excel, font semi-bold, and I'll give it a specific color. Using these square brackets, we can give specific colors in Tailwind. And here I'll write the name of the website, Mr. Almost MD. And I'll create a container for the two buttons, that is the theme toggle and the settings button. So for that, I'll create a div, class name with full, flex row, justify end, and gap up to. And inside that, there will be two buttons. One is the mode toggle, and there will be the settings button in case of the mobile screen. And for the theme toggle, we'll use the ShadcnUI. So let me go ahead into the Shadcn documentation. So in the Shadcn, I'll go to the docs, and on the left side, I'll click on dark mode, and I'm talking about Next.js. So first, as you can see, we'll have to install the Next themes. Then we'll have to create a component ourselves using theme provider, and that will be imported in the layout.tsx file, and we'll be wrapping the children inside that layout.tsx using that theme provider that we'll be writing. And then we'll have to create a mode toggle component as well, which we'll be able to import on any page, and that will look like this, using which we'll be able to change the mode of our page. I will install the Next theme. So I'll stop the service here, Control C. After that is installed, I'm going to create this component. At the root of my project, I'll right click and select new file and paste it. That is going to create a theme provider.tsx file inside a components directory. And here I'm going to copy and paste this code. After that, we'll be importing this theme provider that we just created here inside the layout.tsx file, and we'll be wrapping the children using this code. And next, we'll be creating this mode toggle component. So I'll copy this code here inside the components. I'm going to right click a new file. I'm going to call it mode toggle.tsx, and I'm going to paste that code here. As you can see, it has some dependencies. So it requires the button and the drop down menu component as well from ShadcnUI. So let's go ahead and install that. npm impx shadcn @latest add button drop down menu, and after that is installed, this is going to automatically get resolved. Now you can import this mode toggle component anywhere in our page. So I'm going to go to the page.tsx file. Inside the header that we created, I'm going to import mode toggle, and it is going to come from the same file where we defined it. Now let me go ahead and bring up the service, npm run dev, refresh the page, and we can see our mode toggle button is there. Now if we click on it, we can see that it's not working, and earlier it used to work out of the box just like that, using the following the documentation that is mentioned in the ShadcnUI. After digging into it, I found that this global.css file has changed. So in the current version of the ShadcnUI, they have changed the global.css implementation. And what happens is if I remove this line, it seems to work, but then again the styling is completely off. So you can see that in the dark mode you cannot tell, but in the light mode you have this icon is not clearly visible and all of those things. So what I'm going to do is that I'm going to delete all of this CSS code, and I'm going to copy and paste the same global.css file that we used to have in the earlier ShadcnUI implementation. So I pasted the code that used to be the earlier implementation of the global.css file from the out of the box installation of ShadcnUI. And after I save it, everything looks like how I used to have it earlier. So it has a nice blue tint in the dark mode as well, which is not present in the latest implementation, but this is something I used to like, and then just because I am using the earlier global.css file. Moving on back into the page.tsx file, right after this mode toggle button, we want to add the drawer trigger in case of the mobile version. So let's first start building on the mobile version, the report component, then we'll be using the same component in the desktop version as well. So for that, we'll go to the ShadcnUI documentation again, and we want the drawer component. So on the left side, I'll select the drawer, and if you select this button here, as you can see, it just pops up a drawer, and inside this will be adding the whole workflow of selecting a report and then extraction of that report detail and then the human eye verification. So let's go ahead and install the drawer component. I'll stop the service here, npx shadcn add drawer, and as I know that I'll also require inside that drawer component input elements like the file input, a button, a label, and all those things. So I'm just going to add all of them in one single line as well. So I will need a input, a text area, and a label. We have already added the button. So if I go to the components directory and in the UI, we can see that we have added the button. So we don't need to add it again. So I'm just going to add all these other components inside in one single line itself. And as you can see, as we install them, they are added inside this components directory. And that is one of the best things about ShadcnUI, that you can go ahead and change the look and feel of these components to suit your design needs. So inside this page.tsx, inside the container that we have created that represents the right side of the header bar. So here I'm just going to write a drawer, and that's going to come from the components and UI directory where ShadcnUI just placed it. And it will have two things, a drawer trigger and a drawer content. So for the drawer trigger, I'm just going to write drawer trigger, and this will have a button that is again going to come from the ShadcnUI button, and I'll make the button as child so that it does not create a separate wrapper DOM element just for this. So the button is the drawer trigger and the drawer trigger is the button. And I will add variant here that is going to be outline. Let me go ahead and bring up the service so that we can see what we are building. npm run dev. I refresh the page here and make it mobile screen. So you can see that the button is there. Now inside that we'll add a Lucid React icon, and Lucid React icon pack got installed when we installed ShadcnUI, so we don't have to separately install it. And here I'll use the settings icon from Lucid React. Now I'll just add another attribute, that is size, inside the button. So that will be the size icon. That will it will be a square button similar to the mode toggle. Now this button is available in the desktop version as well. To change that, I'll give it a class name. So I'll add class name for medium screens or above, make it hidden. So that way when it is medium screen or large screen, the button is not visible, but in case of mobile screen, it becomes visible. Now I'll go ahead and add drawer content, and inside the drawer content, I want to create a component. The reason I want to create a separate component is because it has some involved workflow. It will be easier to maintain if we can create a separate component. Not only that, the same component will not only reside in the drawer content, it will also be the same set of code when we'll be writing it as a component on the left side of the page in case of desktop. And for that, since we don't want to write the same code again and again, so it's better if we can create a separate component here. So I'm just going to name it report component, and I'll go to the components directory and I'll right click new file, report component.tsx, and here I'll use the same tsrafce ES7 plus code snippet, and I'll rename it report component, and here I will import this. Now if you go ahead and click on this button, we can see that it is coming. The text is report component. The reason is that in the report component we have that text itself. But why don't we go ahead and give this drawer content a little bit height? So I'll add a class name in the drawer content, that is class name height is equal to 80% of the view height. So that way we'll have some height, and then we can go ahead and build this report component inside this drawer content. So I'll go to the report component that we just created, and I'll create it as a div, and I'll give it a class name grid with full items start gap of 6 overflow auto, so that we have a scroll bar if you have a lot of text and a very short screen, and padding of 4, and padding top I'm going to make it 0. Inside that I'll create a field set and give it a class name relative grid gap of 6 rounded large and border and padding of 4. Inside that I'll create a legend. I'll call it report and give it some class name text small and font medium. Right under that I'll create an input element, and I'll fetch it from the ShadcnUI implementation where Shadcn placed it, and I'll make it type file, and I'll create an on change placeholder because whenever the user selects this report, I want to convert it into a base64 string. So I'll call this method handle report selection, and I'll place my cursor here and hit command dot and add missing function declaration. So it adds this function here. I'll import this change event, update import from React, and it says that since we have added an input element, so we need to make sure that this component is using the use client directive, and the best practice is to add the use client only at the component level. But since the page will have two components, that is the report component and the chat component, both of which will require the use client directive. Not only that, the home component will also have some state management, which will use the use state hook, which also requires the use client directive. So what I'm going to do is that in the home component that is inside the page.tsx file itself, at the top, I'm just going to write the use client directive so that I don't have to write it again and again. So back in the report component, right after the input, I'm going to add a button from the ShadcnUI button, and that will be the first of the workflow, that is upload file. I'll give it the on click placeholder for now, that is extract details. It will send a API request to the Gemini API as a vision task, and it will extract the details that it sees in the report file, be it a PDF or a image file. So I'll do the same thing, place my cursor here and hit command dot, add missing function, and it does not require any parameter. Right after that, I'll add a label from the ShadcnUI, and when we installed it, it also created this radix UI directory, but make sure that you import it from the UI directory right here where ShadcnUI placed this label code. And for the label, I'm just going to write report summary, and under that there will be a text area. For the text area, I'm going to write a placeholder. Extracted data from the report will appear here. Get better recommendations by providing additional patient history and symptoms. And I'll give it a few class names. I'll give it a minimum height of 72, resize none. So that is going to remove this resize handle. So if I save it, you see that's gone. I'll give it a border 0, padding of 3, shadow none. And whenever we select this, it adds this very thick border, and that does not look very good in case of light mode. So if I show you that, I think it looks very, very thick. And for that, I just like to remove that using focus visible ring 0. So whenever we are inside the text box, it does not add that thick border. Right under that, we'll add the confirmation button. This will be the second step of the workflow. So it will say looks good. And just to emphasize the importance of this step, I'm just going to give it a class name and background, the same red color that we used for the name of our web app. So when we hover over it, as you can see, this becomes black. So let's go to the ShadcnUI implementation of the button. You can see it comes with specific variants. So the default variant is default, and we also have other variants like destructive, which is basically a red button, and we have outline, secondary, and ghost. So we can go ahead and make this button destructive. That way it will have the specific styling of the destructive button, and that will match with the red look that we are aiming here. So on the button code, I'll write variant destructive. That way it's a red button. And when we hover over it, this is going to take the hover styling of the destructive button. Okay, so far we have implemented the UI part of the report component. Now let's go ahead and add some functionality to it. When the user clicks on this input element, a dialog box pops up like this. And here the user can select a specific PDF or image file. And when the user either selects the file or hits the cancel, this onChange event handler is going to be called, and this handle report selection in turn is going to be called. So basically first I'm going to check if the user did close the dialog box by selecting a specific file and it's not empty. And after that, I'll do a file type verification. We'll only allow PDFs and images to be uploaded. We don't obviously want any video to be selected. I'll also implement compression of the image, as phones these days take very high quality images, and that much image quality is not required for the vision models, and unnecessarily eats up a lot of token within that context window. As according to my testing, I didn't find any difference in terms of the extracted details when I used 10% of the image quality. For PDFs, it is best to use external libraries for PDF compression. For that reason, I think it's best to implement a server-side compression before sending it to the Gemini API. Then again, we're talking about sending that sensitive medical information to an external API or storing this medical information in an external database or something like that. For that reason, I'm not going to go to that route of PDF compression. In fact, all the compressions will happen on the client side itself, and I'll be implementing image compression on the client side in this video, but I won't implement any PDF compression in this one. If I later happen to extend this app to include PDF compression, then I'll leave a link to that right here. So as we said, inside this function, first I'm going to check if event.target.files does not exist. Then I'm just going to return from here. And then if it does, then I'm going to get the first file. So const file is equal to event.target.files0. So I'm not going to implement multiple file selection, but obviously if you want that feature, then you can extend it here to allow the user to select multiple files and then extract that and convert each of them into base64 string before sending it to the Gemini API. If file exists, then I'm going to define two Boolean parameters, that is valid image, and set it to false, and do the same thing for the doc, is valid doc is equal to false, and define the valid images MIME types, const valid images, and I'm going to allow only the JPEG, PNG, and WebP, and for docs, I'm only going to allow the PDF. Now I'm going to check if valid images dot includes file dot type. So this file dot type is going to give us the MIME type of that selected file, and we're going to compare that, and if it is match, then it's going to be a valid image is equal to true. So it is going to be is valid image is equal to true, and do the same thing for the docs. So valid docs, then is valid doc is equal to true. Now if it's neither a valid image or a valid doc, then we are going to show a toast to the user that you did not select the right file type. So for that, I'm going to use the toast element from ShadcnUI. So I'm going to go to the ShadcnUI documentation, and on the left side, I'm going to choose toast. So we want something like this to be shown to the user. So first we'll have to install the component. So I'm going to copy this command, stop the service here. So you can see it added a hooks folder onto the project root and added a use toast lifecycle hook. So using this, we'll have to implement the toast. So as you can see, first we'll have to import this toaster that comes from the package that we installed in the layout.tsx file right under the main content, and then we'll have to import this hook into any of our component, and then we'll be able to use it like specifying the title and description to show the toast. So let's go ahead. We'll just copy this import, paste it in the layout.tsx file at the top, and I'll put it inside the theme provider so that the theme also gets applied to the toaster element. And after that, I'll import it using this statement into our report component. And here we'll be using this use toast hook, and we'll be using this toast method to show the toast. So we have already made the checks that if it is a valid doc or valid image. So I'm going to write if it's not a is valid image or a is valid doc, then I'm going to just show that toast. And here I don't need the title. I'm just going to say in the description that file type not supported, and I'm going to set the variant to be destructive so that it's a red toast. Now if you bring up the service npm run dev, now if I go ahead and select a text file, for example, we can see that it says file type not supported. But if I go ahead and select WebP, then we can see that it allows us to select that file and we don't get any toast. And of course, from this function, we are just going to return because we don't want to continue after we selected a wrong file. And if we have selected the right file, then we can go ahead and convert it into a base64 string. So for the easy one, the PDF selection, we don't want to do any compression. So I'm going to say is valid doc. Then I'm going to instantiate a reader, and this is going to come from web API. So you don't have to install any specific libraries for this. So new file reader, and we are going to say reader dot on load end. We're going to define this callback function beforehand, and we're going to say reader dot read as data URL, and we're going to pass the file. So when we call this function internally, this callback function is going to be called. That is why inside this callback function, we're going to write const file content is equal to reader dot result as string, and this is going to be the base64 string equivalent of that file. So we're going to go ahead and console log this just to show. I'll bring up my console here. If I go ahead and select a PDF file, we can see that we have the PDF MIME type and the base64 string right after that. So we have done it for the PDF file. Now let's go ahead and convert the image also into a base64 string. So if it is going to be if is valid image, we're going to first compress the file. So we're going to write a function compress image, and it takes a file, the file that was selected, and after the compression is done, it is going to invoke a callback function. So that is going to be compressed file, that is going to be of type file. Inside this callback function, whatever we did with this PDF file, we're going to do the same logic. Only thing is that we are going to do that with the compressed file. So here in place of this file, we are going to replace that with compressed file. So let's go ahead and create this function. I'm going to place my cursor here and hit command dot add missing function, and it created as a standalone function. That is fine because it does not require any dependencies. It just takes a file and converts it and calls it using the compressed file. I'm going to rename this as callback. Now let me go ahead and paste this function implementation, and I'm going to walk you through it. So inside this compress image function, what we're going to do is that just instantiate a file reader. Then we're going to create an image object, and basically we're going to create a canvas and draw that image on that canvas, and then convert that canvas into a data URL with image.jpg MIME type. So this line is also going to compress that image and convert that into a JPEG file, since we're converting that canvas. And then from that, we are going to create a byte string, and that is going to be converted into a file, and that is going to be the compressed file. And the callback is going to be called using that compressed file. And this logic that we did for PDFs, the same logic will receive that compressed file and convert it into a base64 string. Now if I go ahead and test it, I'm going to go and select a PNG file. So you can see this is about 235 KB in size. If I select it, you can see that it first got converted into a JPEG format, and the base64 string is about 29.8 KB. So that is going to be about 10% compression. Now rather than console logging it, let's go ahead and save it in a state variable. So at the top, I'm going to define a state parameter, state snippet base64 data, and this is going to be empty string initially. I'll import it, and here right after the console log, I'm going to say set base64 data is equal to file content, and do the same thing for the image as well. And that's it. We have converted the PDF or image into a base64 string. Now we are ready to go ahead and send it to the Gemini API via a API call. Okay, now let's go ahead and build the extract details function. So when the user clicks on this button, this should send a API request to Gemini API. So inside this function, first I'm going to check if a base64 string was extracted. So I'm going to check if base64 data does not exist. Then we're going to show a toast with description, upload a valid report. And this is going to be a variant destructive, and we're going to return. If base64 data does exist, then we're going to send a API request. So I'm going to write const response is equal to await. Since we're saying await, that means we'll have to make this function an async function. So we're going to say fetch, and we'll create an API here. So API slash extract report Gemini, and this will have the method as post. Headers will have content type application JSON, and in the body we'll use JSON.stringify and send the base64 string with base64 key, the base64 data that we saved. So after we receive the response from this API that we are going to write after this, I'm going to check if response.ok. We're going to get the text out of the response. So we're just going to send text from this API that we will be implementing. So I'm going to write report text await response.text. So usually we do response.json to get the return JSON object, but we'll not be sending any JSON object. We'll just be sending the extracted report text. So we'll be using the response.text function here. And I'm going to console log this report text. Actually, I just realized that I was writing this if statement inside the fetch call itself. So I'll just have to bring it down. Now let's go ahead and create this API. So in the app directory, I'm going to right click, new file, write API / extract report Gemini / route.ts. So it is going to create a route.ts file inside the extract report Gemini directory, and which will be created inside the API directory under the app directory. That means this folder structure is going to make sure that there will be an API with this name created in the Next.js app. So here we're going to export an async function called post, and it will receive a request of type request, a response of type response. So the first step will be unpacking the base64 string that represents the file selected that was sent as part of this post request. So I'll be writing await request.json that is going to give us the payload object, and we are just going to unpack the base64 key using which we are sending that base64 data. This key should match inside the report component, this key which we are sending using this format as a JSON payload. So back in the API, we'll be now using the npm package for the Google's Gemini API. So for that, let me go to the documentation first. Okay, so if I go to Gemini API docs, build with Gemini API reference, and here I'll select Node.js. So you can see that we'll have to first install this npm package and then get an API key, and then we can import the generative AI module using which we'll be able to configure the model with the model name and some additional parameters like safety settings, etc. Now, if I go to generating content and then scroll down to vision tasks, and you can see here that they have given a function file to generative part, which takes a path and a MIME type, using which they create a specific format JSON, which this API expects. So let's start it from the top. So first we'll be installing the npm package. So I'll copy this line, stop the service here. After that, I'm just going to go to this link, and that is going to go to the Google AI Studio, and you can click on this button, get API key. I've already created one API key, but if it is your first time, then you can click on this button and you can create an API key. I'm just going to copy it from here. And in the root of my project, I'm going to right click and new file .env and save it with the name Gemini API key. And I'm going to make sure that in the gitignore file, I add that .env file extension as well, so that when I publish it to GitHub, this secret key does not get published into the GitHub. So back in our API, we'll first import the Google Generative AI module that we just installed. So import Google Generative AI and get an instance of it, const gen AI is equal to new Google Generative AI, and it requires an API key, as you can see. So here we'll be passing process.env the name using which we stored our API key. And here I'll have to use the assertion operator to tell TypeScript that we have saved it using this name, so it will be available in the runtime. Then we'll create a model. So const model is equal to gen AI dot get generative AI model, and it also takes a configuration object where you can specify the model name which is required. So in our case, we'll be writing Gemini 1.5 Pro. Also, you can specify other parameters like safety settings and all of those, but I'm not going to set those here. I'm just going to keep them at their defaults. So using this base64 string, we are going to create that prompt. So I have created a modified version of that function that we just showed. So if I go to the vision tasks, so generating content, then vision tasks. So as you can see, it takes the path and then reads using file system and then creates a base64 string and also attaches the MIME type. In our case, we don't need the path since we have already converted it into a base64 string. We're using the split using comma to get the MIME type and the base64 string. Just so you know that you can also send multiple files to this API. So when I said that I'm only going to work with one file selection, you can very well go ahead and allow the user to select multiple files and convert each of them into base64 strings and then send all of those files into this API using this modification. So inside this post handler, I'm going to write const file part is equal to, I'm going to call that function file to generative part and send the base64 data. And I'm also going to use a text prompt. So I'm going to write attached is an image of a clinical report. Go over the clinical report and identify biomarkers that show slight or large abnormalities. Then summarize in 100 words. You may increase the word limit if the report has multiple pages. As you'll see when we'll be testing with PDF, it will have multiple pages in that report. And I'm going to say do not output patient name, date, etc. Make sure to include numerical values and key details from the report, including report title. And then I'm going to ask for the summary. So here I'm going to write const generated content is equal to await model dot generate content. So it has two methods, generate content and generate content stream. We are not going to stream the response for the report extraction, although in the chat component we'll be streaming the response, but here it's only 100 words, so we'll just be extracting the text and send the text to the client. So I'm going to use generate content and here send the array, first of which will be the prompt and the second part will be the file part, which we received in the specific format as a JSON object. Now let me go ahead and console log this, console.log generated content. Now we have to return something from this post handler, otherwise it will throw an error. So I'm just going to return a dummy response for now. Return new response, dummy response, and status is going to be 200. Now I'll bring up the service npm run dev, refresh my page, go ahead and select a report file in the WebP format and click on this upload. So we are not console logging before it sends the request to the Gemini API, but we have received a response from the Gemini API. As you can see, it has a text function using which we can get the text of the generated content. So let me go ahead and do that. Const report text is equal to generated content dot text. Actually, the text comes inside the response. This is one of the best things about TypeScript because it will come with the IntelliSense and it will tell you that it should be inside the response object, and then you can call the text function. And this TypeScript definition gets installed since we installed the npm package, and we can return this response text. Now back in the client, in the report component.tsx, if the response is okay, we are console logging the report text. So you'll be able to see that in the client console as well here. So let me go ahead and run this again. I'm going to go ahead and select the same file, click on this upload, and we can see that the extracted report text is in the browser console. Now we can go ahead and show this text in the report summary text area. So for that, I'm going to go ahead and create a state variable. So state snippet report data. Initially, this is going to be an empty string. And when we receive the report text, rather than console logging, we are going to say set report data is equal to report text. And I just realized that this function definition uses return void, but since it's an async function, so you'll have to wrap it with promise. This is just again TypeScript. Now we'll bind this state variable that we created, the report data, with this text area. So I'll go to the text area and here write value is equal to report data. We'll also do a two-way binding. I'll write on change and I'll define it using the arrow function, and it receives a event object. And here we're going to say set report data is equal to e dot target dot value. So this way we're not just showing the report data, the extracted details, but also we are allowing the user to change the report data by editing this text area. Now if I go ahead and do the same run again, select a file, click on this upload file. Of course, this is being extracted, but we'll be showing a loader icon here. And you can see that we got back the text here. And obviously you'll be able to edit that text area, like adding symptoms and etc. Now to show the loading, first I'm going to create a state variable. State snippet is loading. Initially, this is going to be false. And inside the extract details, just before we send the fetch request, I'm going to say is set is loading to true. And when we receive the response okay, after we set the report data, we're going to say set is loading to false. And so inside this field set, right after this legend, I'm going to write a div and give it a few class names, absolute. So we want this loader to only cover the report component. That is the reason why we set this field set as relative. And here we'll be setting absolute Z10 so that it's above everything else. Height full, width full, background card 90. So it will be slightly opaque, rounded large, flex row, items center, and justify center. And inside this, I'm going to write extracting. So this is how this is going to look, but let's go ahead and make it conditional. So I'll wrap it with curly braces and say only when it's loading, ampersand, then only go ahead and show this. Now, if I go ahead and test, I'll just go ahead and select a file, click on upload. We can see that the extracting box is there and we get the report details and we have the ability to edit it. Now we'll go ahead and add functionality to this looks good button. So when the user clicks on this looks good button, what should happen is that this text, whatever is in the report summary text box, the extracted ones and the whatever the user has added on top of that, that text should be transferred to the parent component, that is the home component here, which is basically instantiating the report component. So for that, we are going to create a callback function here on report confirmation. So this is going to be a property of the report component as we are adding here, and it will basically be a callback function. I'm just going to name that callback function the same as on report confirmation, and I'm going to define this function upon top here in the home component. So const on report confirmation, and I'm going to define it as a simple arrow function that takes a parameter called data, which is going to be of type string. So this data is going to be the report data. So whenever this component is going to call this, we'll make sure that it has to call with a string that represents the string that is there in the report summary within that report component. So when we receive that string, what we want to do is that we want to save it in a state variable inside the home component as well. So I'm going to write state snippet report data, and this is going to be initially empty string. I'm going to import this useState hook. So this is one of the reasons that why we use the useClient directive inside the home component itself, because it requires the state variable inside this component as well. So once we receive that callback and the data, we're going to say set report data with this data. And after that report data is updated inside this home component, we are going to show a toast to the user. So we're going to import the useState hook as we did earlier. So I'm going to write const toast is equal to useToast. And using this toast function, we can show a toast in the home component as well. And here I'm going to say description, just simply update it. That's it. Just a quick note, the reason why we use a state variable as compared to a normal JavaScript variable is because whenever a component uses these state variables, as soon as these state variables are updated, as we are doing it here, set report data, whatever component uses that state variable will also be re-rendered using that updated value of that state variable. So later, a mental note to ourselves is that we'll be passing this report data into the chat component as well, where the user will be able to ask questions using that updated report data by sending a separate API call. But whenever the user comes here in this text box in the report component and it updates it and clicks on this button, this callback function is going to make sure that this is going to be updated in the home component as well. And whatever child component uses that state variable, they are also going to be having the updated value for the report data state variable. So with that, now we can go ahead and add this property in the report component. So it's the report component up on top here. I'm just going to define on report confirmation, and this is going to be an arrow function that is going to be called with a string, and it returns a void. And we'll destructure it here on report confirmation. And when the user clicks on this red button, we're going to say on click an arrow function where we are just basically going to call the on report confirmation with the report data that is being shown in this text area. Now, if you test the same workflow, we'll choose a report file, click on this upload button, wait for the extraction. We can add symptoms, click on this looks good, and we can see that the updated toaster is there. Now we'll go to the home component. As you can see, we are showing the report component only inside the drawer, but in the desktop view as well, we want to show it. So right after this header, we will lay out the main content. So I'm going to create a main tag here and give it a class name. I'm going to lay it out as a grid, x1, so that it takes the available space, gap 4, overflow auto, and a padding of 4. I'm also going to add 2 more class names. So what we want is that when it is a large screen, we want the screen to be split into 3 columns, and on the leftmost column we want to show the report component, and when it is medium screen we want 2 columns, and on the left column we want the report component to be shown. So for that, I'm going to write for medium screen grid columns 2, for large screen grid columns 3. Inside this, as we said, there will be 2 divs. The first one will be the container for the report component. So I'm going to give it a class name, and this will be hidden and only visible for screens medium or higher size. So I'm going to say for medium, it is going to be flex and flex column. And for small screen, it is going to be hidden. And inside this, I'm going to again use the same code, that is report component. In fact, I can copy and paste this code here. If you save it and if we increase the page size, we can see that the report component is available on the left column, and it is split in 2 columns. If we increase the page size to make it a large screen, you can see that the page is split in 3 columns, and on the leftmost column we have the report component. Now, if we reduce the page size, we can see that for mobile screens, it is not available. Only way to access this is to click on this button, and we can see it in the drawer component. So that completes the report component. Next, we'll be creating the chat component inside this container that we have created. So let me go ahead and create a component for that. I'm going to call it chat component. And as we said that this will receive the report data that we saved here as a state variable. So why don't we create that property here as well? So report data property is going to receive the state variable. I'll go ahead and create this component. Inside the components directory, I'll create a new file, chat component.tsx. I'll use the tsrafce and rename it as chat component. If you save it, and then I'll go ahead and add an import statement for that. We can see that we have our chat component. Now we'll go ahead and add this property. So in the chat component here, I'll write report data. This is going to be of type string, and I'll destructure it here so that we can use this property inside this code. So as you can see, we have specified 2-column grid for medium screen, and for large screen, we have specified 3-column grid. So we'll have to make sure that the chat components container takes 2 columns when it is a large screen. So we'll mention it by using a class name for large screen called span2. If we quickly add a background here, then we can see that for the small screen, we have only the chat component, and for medium screen, the right column is taken by the chat component as usual, and for the large screen, it takes 2 of the rightmost columns. So I'll go ahead and remove this. Now inside this chat component, we'll give this div some class names: height full, background, muted, 50, relative, flex column, minimum height of 50% of the view height, rounded, excel, padding 4, gap of 4. So we have a light tint, and in the dark mode as well, we have this light 50% opacity background. As a first element, we'll add a badge at the top right corner that is going to tell the user if the user added the report in the report component. If it didn't, then it doesn't make sense for the user to ask questions. So I think that is going to be a helpful notification to the user. So first I'm going to add a badge, and for that I'm going to install the badge component from Shadcn. So I'm going to go to ShadcnUI, and on the left select badge. So something like this we want at the top right corner of our chat component here. So we'll install this component, stop the service here. I'll say yes. You can see the badge component got added inside the UI directory. Now I'll import this badge component in the chat component, and inside this I can add this badge. I'm going to say variant is outline. I'm going to bring up the service to see as we develop npm run dev and refresh this page. Inside this badge, I'm going to first check if report data, which we received as property, if that exists, then I'm going to show report added, else I'm going to show no report added. If we refresh the page, we can see that the badge is taking the full width, but we can make it absolute. So we'll give it a class name absolute, right 3, top 1.5. That way it will be at the top right corner. And this is the reason why we made this parent div a relative. Now, if we write something, some report data, click on this looks good, we can see that the text turns into report added. Why don't we add a conditional color to it as well, a green color? So for that, I'm going to wrap this in curly braces and make it a tilde notation. And using $, we can inject conditional checks here. So I'm going to do the same thing. If report data exists, then I'm going to add a background color, a specific shade of green using square brackets. If report data does not exist, then I'm just going to write an empty string. Now the best practice is, since it's only one condition, one side of the condition, so that means we can just make it ampersand and remove this second condition. That way, whenever there is report data, it's green. If I remove this and click on this looks good, we can see it says no report added. And as soon as we add a report data, either by extraction or by adding it manually, we can see that it turns green and it says report added. Now after this, there will be the text boxes that will be the questions that the user has asked and the response it has received from the AI. All of those text will be appearing right after this. So that will start from the bottom. So for that, I'm going to add a div with flex1 class so that div takes all the available space. That means that all the other elements is going to be pushed to the bottom. So I'm going to write div class name flex1. So I build the UI part for the chat component. Now we'll go ahead and add the functionality for managing the state of the chat, and to stream the responses, I'm going to use Vercel's AI SDK, and I have already created an in-depth tutorial for that. But in this one, just to be comprehensive, I'm going to quickly go over the documentation. So if you search for Vercel AI SDK, and on the left side, I'm going to choose Next.js app router. And here you can see you'll have to install a specific npm package called AI. And this does not require any API key or anything like that. It's just because of the example that they are showing. And it comes with two things. On the server side, you'll be writing the post handler in the way you'd write any other Next.js API. And only difference is that you'll be using this toDataStreamResponse function to return the streaming response. And on the client side, it comes with a useChat hook. This works on the principle of internally managed state and exposing certain handlers, which you will have to hook with your page elements. So for example, this messages array contains all the messages that has gone back and forth between the client and the server. This input and handle input change, you'll have to hook up with the input text area where the user will be typing the user query. And that is going to make sure that when you call this handle submit, that is going to handle the API request to the API server here. It is going to make sure that that input text that the user has typed in gets added to the messages array, and that messages array gets sent as a JSON payload to that API. So this is how this AI NPM package, or the SDK as Vercel likes to call it, makes it very easy to display and interact with the chat state of our app as well as stream the responses. So with that, we'll start from the top. We'll first install the AI package. So I'll stop the service here, npm AI. After that is installed, I'm going to start with the client side. So first I'm going to import this useChat hook at the top of my chat component. And I'll also use this line to expose the handlers, which will be connecting with the page elements. So the first of all, we'll have to loop over this messages array to show the chat boxes here. So right after this div flex1, I'm going to create another div, give it a class name flex column, gap of 4. And inside that, I'm going to use curly braces, messages.map, and it takes an arrow function, and it should return a JSX code. And in our case, we are going to create each of those message box as a separate component, since it will have certain other code like handling markdown, etc. So I'm going to separate it out in a separate component. So I'm going to write message box, and this map function obviously iterates over each of these messages. So it will receive that message object as well as the index, and we'll have to add a key attribute to each of these components, which are in the same hierarchy. This is for React, and I'll be using the index to identify each of those components. I'll also add two more properties to this message box, which are very obvious. First of which is the role of the message. So it will have role like assistant or the user, and I'm going to send that as a property called role, m.role, and content, which will be basically the text content of that message object, m.content. Now I can go ahead and create this message box. So inside the components directory, I'm going to create a new file, message box.tsx. I'll use the tsrafce code snippet, name it message box, add an import here, and go ahead and create these properties inside the message box component. So first one is role of type string and content of type string. Inside the message box, we are going to show a card from ShadcnUI. So I'm going to install that component, npx shadcn @latest add card. And after that, I'm going to add that card here, bring it from the UI directory, and it will have a card content and a card footer. The card footer will only be visible for the messages that are not user. So for anything that is not a user message, we want to show a disclaimer that this recommendation is only for informational purposes, and this should not replace a qualified advice from a medical professional. I'm going to write card content, the first one, and it will basically have the content that we have received as a property. So we'll have to destructure these two properties here just so that we can use them in our code, role and content. And inside this, I'm just going to write content. This content will be a text that also will contain markdown syntaxes, and showing it as plain text will not be very visually appealing. And later we'll be implementing a markdown conversion here so that it looks the way the markdown should be looking. But moving on, I'll be writing the card footer, and inside that I'm going to write a disclaimer. I'll give this footer a subtle presence by adding some class names: border, top, background, muted, 50% opacity, padding X of 6, padding Y of 3, text extra small, text muted, foreground. And for the card content as well, we'll make this little smaller and give it the same padding. So class name padding 6 and text small. I forgot that we'll have to make this footer conditional. So this should be only in case of, as we said, a message that is not from user. So I'm going to wrap it in curly braces and write role is not equal to user %. So that is going to make sure that this only is displayed when the message is not from the user. So back in our chat component, we are looping over the messages object to show the message boxes for each of the message. Now, after that, we want to show the text box area where the user will be typing their query. So for that, I'm going to create a form. So right after this div, I'm going to write form, and I don't need the action. I'll give it some class name, first of which is relative, because I'll be adding a button inside that form, and that will be a floating button. Overflow hidden, rounded, large, border, and background. Inside the form, I'm going to add a text area from ShadcnUI as we installed earlier. And I'm going to do a two-way binding with this input and handle input change. So first I'm going to write value is equal to input, and on change is equal to handle input change. This is going to make sure that when we call this handle submit function and that sends a request to the API, this input is going to be added inside the messages array, and that messages array is going to be sent as a payload to this API. Now you might be wondering which API. So by default, this useChat hook looks for an API called API/chat, but you can obviously go ahead and specify your own API name. So in our case, we'll be adding a configuration object here, API, and we'll be specifying the name as API/Medi/Chat Gemini. I haven't created the API yet. I'll be creating this API inside the API directory as we have created the other one. But let me go ahead and finish this code here. So let me bring up the service first, npm run dev. I'll refresh the page. So I'll add a placeholder to this text area and give it some class names to style it. So placeholder, type your query here. I'll refresh the page and give it some class name, minimum height 12, resize none, border 0, padding 3, shadow none, focus visible ring 0. And now we'll go ahead and add the button. So inside the form, right after this text area, I'm going to create a container for that button. Give it class name flex, items center, padding of 3, padding top 0. For the button, I'm going to get the button from the ShadcnUI as we installed earlier. Inside that, I'm going to write first 3.ask as it is the third step. And I'm going to give this button class name margin left auto. I'm going to make the type of the button as submit, as this is going to submit the form. I'm going to make the size small. And after this text, I'm going to add a lucid react icon, corner down left, and make it smaller by giving it a class name, size 3.5. Now, when we have sent a request to the API and we are waiting for the response to come back, we want to show some sort of loader, and that is again going to be exposed by another attribute called isLoading from the useChat hook, and using which we can show the loader icon. So for that, we'll change the text to analyzing. So I'm going to wrap it in quotes and then curly braces, and then check if it is loading. Then I'm going to show the text analyzing, and if it's not loading, then just show the same 3.ask. If I negate it, then we can see that this is the text that it will show. And for the icon as well, I'm going to do the same thing. If it is not loading, actually, we're going to do the same thing. If it is loading, then we want to show a different lucid react icon. I want to show a loader. And if it's not loading, then I'm going to go ahead and show the usual corner down left icon. If I negate this again, we can see this is how the loader is going to look. Obviously, first I'll be adding the same class name, size 3.5, so it becomes smaller. And I'll also add animate spin, a tailwind class, to give it this rotating animation. Now I'll remove this negation so that the logic is correct. And as a last step, I'm going to also add disabled when it is loading, so that the user cannot click this button when we're already waiting for a response to come back. Now, when we click on this button and we are submitting the form, we want to write on submit here, and usually we'll be just connecting the handle submit that comes from the useChat hook with the on submit handler of the form. And that would make sure that whenever we're submitting the form, this input gets added to this messages array, and that gets sent as a default payload to the API specified. But in our case, we also want to add the report data as we have received as a property along with that default payload. So we'll be calling this handle submit explicitly. So we'll replace this with a arrow function. And since it's an on submit of a form, it will receive an event. And first thing what we'll do is event.prevent default. Then we'll be going ahead and calling the handle submit. And as a first argument, it expects that event object. And then as a second argument, we can send additional payload using the data attribute. So here we'll be just sending the report data with the key report data. So this JSON object will be sent on top of this messages array. And when we implement this API inside the API directory, the first thing what we'll do is that we'll extract the payload and console log it, and then we'll be able to see the exact JSON payload that we receive in the API. Now let's go ahead and create this API. So I'll copy this name inside the API directory. I'll create a new file, medichatgemini/route.ts, and I'll write the post handler the same way I write any usual post handler in an Next.js app. So export async function called post, and it receives a request of type request and a response of type response. And the first thing, as we said, we'll do is get the payload out. So we're going to say await request JSON, and I'm going to write const request body. And first thing, as we said, we'll be console logging it, request body. Now, as we have learned from the documentation, that we should be returning using toDataStreamResponse function, something like this. But before that, we'll have to create this result, and that will be a result out of doing all the steps of first querying the vector store, get the RAG retrievals, create a prompt, hit the Gemini API, get a stream from the Gemini API that will represent the streaming response, and that will be sending back using the toDataStreamResponse function. But just to see the payload, let me return a dummy response for now. Return new response, dummy response, and status 200. Now I'll write some report data placeholder. I'll click on looks good. I'll add some query like how is the report. I'll clear this terminal here, click on this ask button, and we can see that we have received the messages array, as we said, with the role user, because this is the user message and the content is basically how is the report. Also, we have additionally added the data payload, which has the report data as we have typed here. Now I can see that I made a mistake in the logic because the user message, as it seems, is being shown with the disclaimer, which should not be the case. So I'll go to the message box. As you might have already noticed when I was typing this should be double equal sign. That way the user message will not have the disclaimer. Only when we receive a response from the API here, that will have the disclaimer. So with that, we are ready to go ahead and query the vector store and then build an elaborate prompt for the Gemini API. Then we'll create a stream and return the stream using this toDataStreamResponse. Now I'll go ahead and create the query for the similarity search by combining the user query and the report data. So first I'll get the messages array here. So const messages is going to be of type message, an array of messages. So that is going to come from this AI React package that we have installed. An array of that is going to be equal to request body dot the messages object. And then we're going to get the user query that was just typed in by the user. So I'm not implementing a multi-turn chat here, but if you want to implement that, then you can use this messages array itself and send it to the Gemini API to implement that. But in our case, I'm just going to get the last user query that the user typed in. So that is going to be user question is equal to messages dot length -1 and the content of that. And I'm also going to get the report data. Const report data is equal to request body, and it is in the data dot report data. Now I'm going to build the query for the similarity search. So I'm going to write const search query is equal to patient medical report says new line, and here I'm going to inject the report data and then a paragraph, and the user question will be injected here. Now for the similarity search, I'm going to create a Pinecone client. So I'm going to go to the documentation. I'm going to click on in the pinecone.io. I'm going to click on docs, then guides, then I'll go to the JavaScript section, and you can see that this is the same way what we used to push into the RAG knowledge base. The same client will be using the same npm package that we'll have to install, instantiate it using the API key, and then we'll be able to use this code to specify the index and the namespace to query the vector store using a specific embedding. So let's start it from the top. I'll just install this package as we did earlier in our last video. I'm going to copy this line, stop the service here. Now we have already created an API key, so I'll just log in. Since we have inserted into the Pinecone database, we have already created an API key. So I'm just going to go to the API keys section from my dashboard, and I'm just going to copy one of the API keys here. And in the .env file, I'm going to save it with the name Pinecone API key. Now we'll initialize it using the same code that we did before. So in the app, then API Gemini route.ts at the top, I'm going to add that import line as well as the initialization of the Pinecone client. And in this API key, I'm going to mention process.env dot pinecone API key. Now I'll have to use the assertion operator here just to tell TypeScript that we have saved it using this name and it will be available in the runtime. Now all the processes of querying the database and returning the retrievals, I'm going to create a separate utility function for that. So at the root of my project, I'm going to right click and new file utils.ts. And here I'm going to say export async function called query pinecone vector store, and this is going to receive a bunch of parameters, first of which is going to be the client that is going to be of type pinecone, and the type is going to be imported from the npm package that we installed. It will also receive the index name of type string, the namespace of type string, the query or rather the search query that is going to be of type string, and since it's an async function, it should return a promise which resolves to become a string, and that string is going to be a concatenated list of all the retrievals or rather the top matches from the vector store. So I'll just write return an empty string for now, just so that we don't see that compilation error. And I'll go to the route.ts, and right after this, I'm going to call that function. So I'm going to say await query vector store and going to import it from that utils class. And I'm going to pass the PC, the Pinecone client instance that we have created. For the index name, I'm going to go to the my Pinecone dashboard, and in the database, we created the index name medic. So I'm going to call it medic. Inside the medic, if we go to the namespaces, this is a test namespace that I had created, but the namespace one is the namespace that contains the knowledge base. So I'm going to copy that name and use that namespace here. And then we're going to pass the search query that we built that contains the user query as well as the report data and some prompt. And this is going to return a string. So I'm going to write const retrievals is equal to this thing. Now let's go ahead and build this function. So when you're talking about similarity search, we are talking about comparing vector to vector. So this search query is now in text format. So we'll have to convert that into an embedding as well using the same embedding model that we used to build the knowledge base. And only after the comparison returns top results, we can unpack the text that is attached as a metadata to that vector. If I quickly go to the database and inside the medic index, I'll click on browser, and here the namespace one is selected. So each chunk has a values that represents the vector, and we have stored the actual text using a chunk key inside the metadata section. So these values will be used to do a similarity search, and then only top 3 or 5 matches come up. We'll be unpacking this text from that vector to build the final query. Now we need to do a similarity search between this search query and all the vectors that are stored in our RAG knowledge base. For that, we need to convert this query into an embedding as well. Now, while creating our knowledge base, this is the model we used, and we'll use the same model for creating embedding for the user query as well. Now here you can see that they suggest that we provide this specific prefix when we are generating the embedding for retrieval. So I'm going to copy this section, and before this search query, I'm going to add that. So this is going to be our search query. Represent this for searching relevant passages, and then patient medical history says the report data and the user question. Now, when we are talking about creating embeddings for all the documents that we push to our knowledge base, we are talking about creating embeddings for thousands of text snippets. That's why it made sense to use the transformers.js library to pull a local copy of this model and spin up a local instance and then create all those thousands of embeddings. But in this case, it will only create one embedding each time a user query is sent. So we can go down the path of API. This will also help us in deploying this app in a serverless way. So here I can see that it supports the Inference API. Now I have created an in-depth tutorial on how to use this API in your Next.js application. It is pretty straightforward. So I'm going to go to the docs section and click on Hugging Face JS. So here you will have to first install an npm package and then specify the task name and the model name, and you can send the inputs, and we'll be sending the text chunk in our case, and we'll be receiving the embeddings from this API, and that embedding will be used by this client to do a similarity search. So let's go ahead and install the package npm install Hugging Face /inference. Now I'm going to go ahead and import this and create an instance of that. I'm going to call it HF for Hugging Face, and it requires the Hugging Face token, although it is not mandatory as they mention in the documentation. But just to avoid rate limits, I'm going to go ahead and create a free API key. So after you log in, you can click on this top right icon and then go to settings, and then access token, and then click on create new token. And earlier they used to have only read and write, which I'm also going to use. And if you have a use case where you need a fine-grained control of what that API token authenticates, then you can go ahead and choose specific authorization access for that API token before creating that API token itself. But in our case, I'm just going to go to the read, and I think most of the use cases are covered by read itself. So I'm just going to call it embedding creation. The name doesn't matter really, create token, and then copy this. And in the .env file of our project, I'm going to call it hugging face token and save it with that name. And back in our utils.ts, I'm going to say process.env and use that name that we saved the hugging face token with. And inside this function, I'm going to write const hf output is equal to await hf dot feature extraction is the task we want to use. And as we mentioned, first we'll have to specify the model name, and I'm going to go to the model card again, and I'll copy it from here. And in the inputs, I'm going to pass the search query that we received. Now let me go ahead and console log what we are receiving from this Hugging Face API as embeddings. So I'm going to write console.log hf output. Now I'm going to bring up the service npm run dev, refresh our page. I'm going to write some sort of report data placeholder here. Click on looks good. It's added. I'm going to ask for how is the report. And when I click on this button, it is going to send a API request to this MediChat Gemini. Here we're awaiting this retrievals using this function. So this is going to call this function here, and we'll be able to console log the embedding version of the user query. Let's see how that looks. I'm going to clear this terminal here, Command K, and click on this button. So you can see that we have created an embedding that again has 1024 dimension. Using that embedding, we are ready to query the Pinecone vector store. First, I'm going to say const query embedding is equal to, I'm going to convert it into a JavaScript array dot. As you can see, this Hugging Face output has a specific type called feature extraction output, which looks like an array, but I'm just going to convert it into a JavaScript array anyway. So Hugging Face output is going to convert and give me a JavaScript array, and that embedding will be using with the Pinecone client. So I'm going to write const get an index from the client. So client.index, and here I'll be passing the index name. So this will give us a pointer to the index in the Pinecone database. Then I'm going to write const query response is equal to await index dot namespace, and here we'll specify the namespace dot query. Here we can specify the top k. So here I'm going to say top k is 5. So we want the top 5 matches, and then the vector that is going to be the query embedding that we have created using the Hugging Face API. Now this vector requires a specific type called record values, but this is again just going to be an array of numbers. So I'm just going to say query embedding as any. I'm going to say include metadata is equal to true because that will contain the text chunks, and I don't want the include values because this is going to be the vector, which is basically a 1024 dimensional number array, which I don't need. Now let me go ahead and console log the query response, and this is going to come from as we receive it from the Pinecone database. I'm going to do the same thing. How is the report, and clear the terminal here, and then click on this button. So first we are going to console log the Hugging Face output, and then it is going to query the vector store, and we have received, as you can see, matches, which has an array and it contains 5 matches. And as you can see, it also has some sort of score and the metadata, which is an object. And we know since we stored it there, it will have a key called chunk, which will basically have the text that is represented by that vector. Now we can go ahead and unpack that. So first I'm going to check if query response dot matches dot length is greater than 0. Then I'm going to create a concatenated retrievals string. Concat retrievals is equal to query response dot matches. As you can see, it has an array called matches, and I'm going to loop over it using the map function, which receives an arrow function with parameters match and index. And here we are converting each of those match into a specific string. So I'm going to say start with a new line, clinical finding. So we are going to call each of these retrievals a clinical finding, and then assign a serial number that is going to be represented by the index +1. So clinical finding 1, clinical finding 2, 3, 4, and 5, because this will be used by the final query. And this is how the model will have a better time in understanding that these are called clinical findings, and this is separate from the report data that is specific to the user. And after that, I'll add another new line and then insert the match.metadata, and the chunk is the key that we used. And it says is possibly undefined. I'll add a question mark here that is going to resolve that TypeScript error. And then after each of those match has been converted into a string with the specific format, I'm going to join all of those strings using a paragraph. So double new line characters. Now, if I go ahead and console log this, and I'll remove this console log here. Now I'll do the same thing again. How is the report? Clear the terminal here. Click on this button. Actually, I just realized that I'll have to return from this map function. So whatever string we return is going to represent the converted string. So after I do that, I'm going to refresh my page here, add a report data placeholder, click on looks good. How is the report? Clear the terminal here and then click on this button. And you can see this is how the concatenated string is going to look like. Clinical finding 1, it will have the text snippet, 2, then 3, 4, and 5. And this string is going to be returned from this function. So I'm going to write here return concat retrievals, and else if we did not get any match or some error occurred, then we are just going to say return no match. And I'm going to get rid of this return statement. Now back in our route.ts file, here we'll be receiving the retrievals. Using that retrievals, we can go ahead and build the final prompt to the Gemini API, stream response from Gemini, and then return that response from this API itself. Let's do a full run here because I want to do it with actual extracted report data. So I'm going to go ahead and choose an actual medical report and click on upload file. After that is extracted, I'm going to click on looks good and I'm going to ask what should I ask my doctor, and I'm going to clear the terminal here. Click on this ask button. So this is the list of extracted details. You can see that the report is CBC and the report also says that the hemoglobin level is falling below the normal range. And you can see that the first clinical finding, which would probably have the highest score in terms of the similarity match, that also mentions that females generally are lower than those in males and is talking about lower hemoglobin levels. Even since the report says that it has 12.5 gram per deciliter hemoglobin in the retrieved extract as well, you can see that it mentions the normal hemoglobin level. And in the next clinical finding, it talks about the WBC, RBC, and platelets, which you can see also being mentioned in the report because it says that the platelet count is borderline low. So these are useful informations coming out from the knowledge base, and this can help the LLM to generate a more informed recommendation. So let's go ahead and use these retrieve snippets to build an elaborate prompt for the Gemini API. Now I have gone back and forth creating this prompt and I'm going to paste it here. So here I have mentioned that here is a summary of a patient's clinical report and a user query. Some generic clinical findings are also provided that may or may not be relevant for the report. Go through the clinical report and answer the user query. Ensure the response is factually accurate and demonstrates a thorough understanding of the query topic and the clinical report. Before answering, you may enrich your knowledge by going through the provided clinical findings. The clinical findings are generic insights and not part of the patient's medical report. Do not include any clinical finding if it is not relevant to the patient's case. So this is making it a big point that if the LLM reflects and finds that some of the clinical findings are not relevant, and as you can tell that some of the clinical findings that will be towards the bottom, which will have a lower similarity score, they might or might not be relevant to the patient's case. So it is asking that LLM that please reflect and make sure that you don't include any clinical finding that is not relevant while generating your response. Obviously, this prompt has a lot of room for improvement, and I did not invest enough time going back and forth creating a concise and very effective prompt. And you can obviously try with different prompt structures and everything. And if you can find out a better prompt, then it would be very helpful if you can post that in the comment section. And then I went ahead and added the clinical report from the extracted report and then the user question. And finally, the generic clinical findings contains all the retrievals that we have pulled from the RAG knowledge base. And then finally, I have asked it to provide thorough justification for the answer it generates. Now we'll go ahead and stream the response using this prompt from the Gemini API. For streaming, as we mentioned that we are using the Vercel AI SDK. So I'll go to the documentation and I'll click on providers. And since we are going to generate using Gemini API, so I'm going to click on this Google Generative AI provider. So as you can see that it also requires a specific package, and we can install this using this command. So I'm going to come here and stop the service, Control C, Command K to clear the terminal, and then npm install AI SDK /Google. After that is installed, I'm going to use this import statement. The first one imports the default provider, and in the default provider, it requires that you need to specify the Gemini API key using a specific name, which is this Google Generative AI API key. Not only that, we have specified in our case using the name Gemini API key, but also in a lot of cases, you might want to change the custom settings. So for that, I'm going to use this import statement instead, paste it here, and here we'll be specifying base URL. So this is the base URL we'll have to use, and we'll be specifying, as we said, the API key, and it will be process.env, and we have saved it using Gemini API key name. After that, we'll be creating an instance of the model. So const model is equal to Google, and as first parameter, we'll have to specify the model ID, and it will be Gemini 1.5 Pro latest will just work. And here you can see that you can configure the model with additional settings as well. So here you can mention safety settings where you have categories like harmful category, dangerous content, harassment, hate speech, etc. So I'm not going to do all of those here. I'm just going to keep them at their defaults, only going to specify the model name. Now inside the post handler, right after we have created that elaborate prompt, we are going to stream the response. So first I'm going to write const result is equal to await stream text. So we'll have to import the stream text function, and it comes from the Vercel AI SDK. So in the example code, you can see that they are using generate text that comes from the AI package that we have already installed. The same AI package also comes with a stream text function that we can use to stream the response. So I'm going to copy that same import statement here and rather import the stream text function. And inside the stream text, we're going to first mention the model as we have configured up above here. So that same model we're going to pass here. It requires the prompt where we'll pass this final prompt which we have created. And finally, we'll have to return the response using toDataStreamResponse function. So return result.toDataStreamResponse, and I'll get rid of this return statement. This is going to make sure that the response is streamed back to the client, and on the client side in the chat component, we are using the useChat hook and we are looping over the messages array, and that is going to make sure that the response is streamed on the browser. So I'm going to save everything and bring up the service npm run dev and go ahead and choose the same CBC report. Click on upload file, wait for the extraction. After the extraction is done, I'm going to click on looks good. It gets added. What should I ask my doctor? And click on this ask button, and we can see that our response is being streamed. As you can see, it has markdown syntax, so this will be bold, and since we are showing it as plain text, so that is why it is not looking very good. So let's go ahead and implement the markdown handling. So I'm going to go to the components and inside the message box. So as you can see here, we are just showing the content as simple text as we receive it. So here I'm going to go ahead and create another component called Markdown, and this will have a content property where we're going to pass the content as we have received here. And I'm going to get rid of this content, and I'll go ahead and create this component inside the components directory itself. Right click, new file, markdown.tsx. I'll use the same tsrafce ES7 plus snippet to create a boilerplate component, name it Markdown. Here I'm going to add an import statement of that and go ahead and create this content property. So here I'm going to write content of type string and go ahead and destructure this here so that we can use it inside this component. Now there are a few libraries which you can use to convert a text that contains Markdown into appropriate HTML tags. So how we want to handle this Markdown is we want to convert this Markdown text into appropriate HTML tags. So there are a few libraries that does that for you. So one of the more popular libraries is Markdown it. So I'm going to go to the npm documentation of that. So you can see here, you just have to use it by installing this npm package. Here you can send a Markdown text like that, and it's going to convert it into appropriate HTML tags. There are a few other options like using links, etc. And you can go to their documentation to see what those options are. And I have done a more elaborate tutorial of that in one of my videos, and I'll leave a link to that here. But for now, I'm just going to go ahead and install it using this command. Stop the service here, command K, install the package. And at the top, we'll have to just create an instance of it. So inside this Markdown component, I'm going to first import it. And as you can see, it says that it requires a definition file as well. So I'm going to use this command to install that as well as a dev dependency. After that is done, it should be resolved. Now we'll be using this MD to convert this text as we have received it that contains Markdown syntax into appropriate HTML tags. So I'm going to write here const result is equal to md.render content, and this is going to be HTML. Now this HTML should be shown inside the component itself. So in React, we can do that using a specific syntax, and let me write it first. So this is called dangerously set inner HTML, and it comes with a very weird syntax. That is, you have to use these double quotes and then double underscore HTML colon the HTML that you want to set it with. And obviously it will not have any children inside it because you are just setting the inner HTML using this HTML in a programmatic way. Now the syntax is like this because React team wants you to go to their documentation and read about it before you use this to set inner HTML. The reason is that when you are injecting some sort of HTML inside your page, the HTML might contain some sort of JavaScript, and that can be malicious and that can lead to cross-site scripting. Now Markdown documentation mentions, so if I go back to their npm package, they mentioned that this is safe by default. If I go to their GitHub page, so it says that if you don't enable HTML, and we haven't while creating this, you can set up that property as true, but we're not doing that here. And even if you do, you can pass it through an external sanitizer package. So even though we haven't enabled HTML, we are going to sanitize the HTML anyway. So for that, I'm going to go ahead and install another package that is called DOM Purifier. This is one of the most popular DOM purifying packages. So as you can see, if you scroll down, they have given some examples. So you can see these HTML tags have some sort of JavaScript attached to them, but the sanitized version will not have any of those. So let's go ahead and install the package using this command. We'll import this using this statement, and same as before, we'll need the declaration files. So we'll be installing them as dev dependency using this command. After that, this should get resolved, and then we'll write const purified HTML is equal to DOM purify dot sanitize, and we're going to pass the HTML. And finally, we'll be using this purified HTML to set the inner HTML. So that will not lead to any sort of vulnerability. Now we can go ahead and do the same run again. I'm going to bring up the service npm run dev, refresh my page here, go ahead and choose the same CBC report, click on upload file. After the extraction, I'm going to click on looks good, ask what should I ask my doctor, click on ask. And we can see that this time we are showing the Markdown syntax. So in the dark mode, I think it's not very much visible, but if I change it to light mode, we can see that we are handling the Markdown. And we also have the disclaimer at the bottom notifying the user that they should not replace any professional medical diagnosis, treatment, or advice. So that's pretty much it. We have created an app that is built on the RAG knowledge base that we created earlier. In this one, the user can upload a report, extract details from that report, go over it, make corrections, add some other details, and then ask any questions about the report. So if I go ahead and ask, how does the report look, and click on ask, it gives us some more details about what to expect in our visit with the doctor. So let me know what you think about it. If you like this video, then you can say thanks by hitting that like button. If you want to see more of this content, stay subscribed, and I'll see you in the next one.